For centuries, this water divided Britain from Europe.
But beneath these waves, engineers built a secret railway. It links Folkestone in England with Coquelles near Calais.
The Channel was not just water, it was identity.
Before the tunnel, every crossing depended on sea and sky. The dream of crossing underground began long before machines could do it. For generations, fear stopped the idea before geology could test it. The answer was hidden in a layer of chalk marl. This rock was soft enough to cut, yet strong enough to trust. Before digging began, the seabed had to be understood. The tunnel would follow the safest path through ancient rock. At last, two nations agreed to build beneath the sea. Construction began from both shores, racing toward the same darkness. Every journey into the tunnel began with a portal into uncertainty.
The tunnel boring machines were moving factories under the earth. Their cutter heads chewed through chalk, 1 careful meter at a time.
Every meter forward created tons of earth that had to escape.
Behind the machine, concrete rings turned raw earth into infrastructure. The Channel Tunnel is not one tunnel, it is 3.
2 large tunnels carry trains in opposite directions. Between them runs a smaller tunnel, the system's hidden spine. Cross passages connect the tunnels, turning distance into escape and access. Even deep underground, the tunnel had to breathe. Fast trains compress air, so the tunnel had to manage pressure.
Invisible air forces became part of the engineering challenge.
Thousands worked where daylight never reached. Progress came through shifts, discipline, and relentless repetition. A broken machine underground could stop an entire nation-sized dream. Above every worker was the weight of the English Channel. Water was the enemy engineers could never ignore. Where ground turned uncertain, crews strengthened it before moving forward. The two sides had to meet in darkness with astonishing precision. From England, machines pushed east through chalk and pressure. From France, machines pushed west toward the same hidden point. It became a race measured not in speed, but accuracy. Surveyors mapped a tunnel that no one could see from above. The railway ran below the seabed, far beneath waves and ships.
Above the tunnel, one of the world's busiest sea lanes continued.
To build the tunnel, crews first built a world inside it. Electricity, pumps, and signals kept the underground world alive. Each concrete ring became a permanent promise against pressure. The finished system would stretch roughly 50 kilometers.
Nearly 38 kilometers would run beneath the sea. Meter by meter, the gap between nations disappeared.
At the final meters, precision mattered more than power. Then, beneath the seabed, Britain and France finally touched. A wall of chalk became a doorway between continents. The meeting was small, but its meaning was enormous.
Digging the hole was only half the achievement.
Steel rails turned the tunnel into a working transport system. Power had to move trains safely through the sealed underground route.
Signals became the tunnel's nervous system. A tunnel this complex is never truly unattended.
The service tunnel allows crews to inspect the hidden giant.
Engineers designed the tunnel assuming problems could happen. Underground fire risk demanded discipline, separation, and controlled escape routes. The central tunnel gives people and responders a protected path. After years underground, the project was ready to surface. In 1994, the Chunnel Tunnel officially opened.
For the first time, the island had a fixed land link. A journey once ruled by weather became a train ride. Above the train is ocean. Around it is ancient chalk. Minutes later, daylight returns on another shore.
Even cars cross the channel by riding inside trains. Freight turned the tunnel into an economic artery. The tunnel works because the surface around it works.
Every train movement depends on timing, spacing, and control.
The tunnel changed how people and goods moved between nations. It made continental travel feel closer, faster, and more ordinary.
The channel remained, but its meaning changed. Great engineering often carries a price larger than expected.
Mega projects fail easily when geology, finance, and politics collide. The tunnel survived because risks were anticipated, not ignored. Even after opening, water control remained essential. A tunnel is not finished when it opens.
At night, the hidden railway becomes a workshop. Tiny defects matter when trains run beneath an ocean.
The walls are watched because pressure never sleeps.
Modern safety depends on sensors, systems, and human judgment.
Every day, the impossible becomes routine.
A natural barrier became an engineered corridor.
The tunnel did not defeat nature. It negotiated with it. The greatest machine on this project may have been geology itself. Machines dug the tunnel, but people made it possible. No single country could build this story alone.
The Chunnel Tunnel is a machine 50 kilometers long.
Passengers see darkness, but engineers see a living system.
Most of its brilliance remains invisible.
The modern world depends on structures we rarely notice.
Its legacy is not simple, but it is undeniable.
It stands as both triumph and warning. The greater the project, the greater the need for humility. Future mega projects still study what happened beneath the channel.
The sea is still there, powerful and unchanged. But beneath it, humans found a passage.
An ancient separation was crossed by steel, concrete, and trust.
Its wonder is not loud. It is precise.
A train beneath an ocean remains an astonishing idea.
Great engineering begins by understanding what it cannot control.
The Chunnel Tunnel remains a wonder hidden beneath the waves.